This lecture is the first of a nomenclature unit. So nomenclature has to do with naming. So how do we name different compounds and how do we write their chemical symbols? The first one is ionic naming, and you are going to want to have your ion packet out for this. So as you start doing more and more practice problems, you're going to get better and better with your ions. But this, just having your packet out will help you just kind of double check yourself. All right, so ionic naming. Ionic compounds are formed from a cation and an anion. So this should be familiar. So cation being your positive, anion being your negative. Remember that your anion names end in "ide", so fluoride, chloride, oxide, bromide, anything that's negative ends in IDE. So we take that normal ending and switch it to an IDE. So what happens is in an ionic compound, our charge becomes neutral. So we have no charge. So we have to keep track of who is contributing what charge to our overall neutral charge. And we're going to do a lot of examples of this. So you'll see that kind of in practice, but just keep in mind that you do need to recognize what the charges are and be aware of what they are. Also, something to keep in mind is, remember, there's those type 2 ions that form more than one charge. So they form more than one ion, meaning they have more than one charge. So you might have iron 2 or iron 3 or copper 1 or copper 3. So it's important to remember that there are things that do not just have a single charge. Like oxygen's always going to be -2. Fluorine's always going to be -1. Lithium always going to be +1. But then you have those ones, especially in those transition metals, also with your tin and your lead, are going to have more than one charge. All right, so just some tips and steps to keep in mind as we go along. You always want to write out the charge above your ion or below, whichever works for you, just so you can keep track of it. And your charges must cancel to keep your compound neutral. So things I already said, but just so we get it written down. All right, so we're going to go both ways, from the compound to the name and from the name to the compound. The easier one, I think, is to go from the compound to the name first. Okay, so we're going to do some extra steps on these just so we kind of keep it, so we are aware of what's really going on here. So not looking at any of the subscripts, so we're not looking at this 2 here. K is potassium, and if you think about what your potassium ion is going to be, it's going to be a +1 charge. Now, your oxygen is a -2 charge. Now, we said earlier that it has to be neutral. So what happens to make this neutral, we're going to multiply this +1 times 2. That's where this comes in. And that leaves me with -2. So now +2, sorry. So my +2 and my -2 now cancel out. That's why I need 2 potassiums. So what we're going to call this is potassium. Okay, so we always start with your cation first, and this O is my anion. Remember, your anions end in IDE. So K2O is potassium oxide. Okay, easy enough there. All right, let's look at this next one, NaBr. So we start out with sodium here. Sodium ion has what type of charge? It has a +1 charge. And my bromide ion has a -1 charge. So they already balance out, so there's no need to change a subscript. So what is this called? Cation stays the same. Sodium Br becomes an IDE. Sodium bromide. Okay? So our next one here, we have CaF2. So Ca is my calcium. So my charge on calcium is, oh, let's erase that. So calcium is +2. And fluorine is -1. But I'm multiplying it by 2, which gives me a -2. Now my charges cancel themselves out. So now I'm left with cation stays the same. So calcium then I have F. My anion becomes an IDE. Calcium fluoride. Okay? Next, what do we have here? We have Al2SO43. All right. One thing to make note of here, this SO4 is in parentheses, meaning that this whole thing is multiplied by 3, okay? Not just the oxygen. So just for future reference. All right, aluminum. An aluminum ion has what charge? +3. SO4 looks an awful lot like sulfate. Okay, here's where your ions are going to really start coming in. Sulfate has a -2 charge. All right, +3 -2 don't equal out, or they don't cancel each other. So this is where you're going to have to do some math. We're going to find a least common multiple. So our least common multiple between 3 and 2 is, LCM is 6. Okay, that's my least common multiple between 3 and 2. So what I'm going to do is I'm going to multiply by +3 by 2. I'm going to multiply my -2 by 3 to get a 6 and a 6. Now I'm left with +6 on my aluminum, and I'm left with a -6 on my sulfate. Okay, so I multiplied, let's do that in purple. I multiplied my aluminum here by 2, so I'm multiplying my +3 charge twice to give me a +6. I took my sulfate and multiplied it by 3. So I took my -2 charge on sulfate, multiplied by 3. That gave us -6. All right, so to name this, cation stays the same. And anytime you have a polyatomic at the end, so like sulfate, phosphate, hydroxide, anything like that, it stays the same. So this is just aluminum sulfate. All right. Last one here. So we have Fe and we have PO4. So I'm going to start with the PO4 because I know that phosphate has a -3 charge. What do I know about iron? I know that iron can form more than one charge. So right off the bat, I can't just assume what the charge of iron is. Now, there are no additional subscripts. So I have one iron and I have one phosphate. If my phosphate is contributing -3, that means that my iron must be contributing +3. So that means my iron has a +3 charge. So the way I'm going to write this is iron 3, all right? So remember how you had to include those Roman numerals on your ion quizzes. Iron 3 phosphate. Okay, so that is going from your symbols to the name. So always remember that your cation goes first in your name, your anion goes second, and that's also the way that's going to be written. Your cation is always going to be written as the first element or ion in your compound, and then your anion is going to be second. So just, you can go left to right on that. All right, so now we're going to go the opposite way. All right. This is where I find that we tend to have a little bit more trouble because we do not keep track of our charges. So I want you to get in the habit of really writing down these charges of everything. All right, so my first one is cesium chloride. So what I said was write out your charges above everything. So my charge on a cesium ion is +1. My charge on a chloride ion is -1. So now, remember, these charges must cancel. Well, right now, +1, -1, they cancel, so I don't need to adjust anything here. So I can just write it as CsCl. I have one cesium, I have one chlorine. Both of them are contributing a 1 charge. Cesium contributing a positive, chlorine contributing a negative. All right, so let's do one that's a little bit more difficult here. Magnesium fluoride. So knowing your ions, magnesium is going to be a +2 charge. Fluorine is a -1. Now I have a positive and I have a negative, but they do not cancel, so I need for these to cancel. My least common multiple between these numbers, 2 and 1, is 2. So I have to multiply this 1 by 2 to equal -2. So that means I have to multiply my fluorine by 2. So when I'm writing this out, how many magnesiums do I have? Just 1. How many fluorines do I have? 2. All right, next one. Ammonium nitrate. So ammonium has a +1 charge. Remember, that's NH4+. That's your only positive polyatomic ion. And then nitrate is -1. So, good thing about these two already, they already cancel for us. So there's no need for us to change any subscripts. So we're going to have NH4. And I'm going to put this in parentheses just so we keep them separate. NO3. All right. Next we have aluminum hypochlorite. Aluminum has a +3 charge. Hypochlorite has a -1 charge. So remember aluminum, so that's Al +3. Hypochlorite is ClO-. My least common multiple between 1 and 3 is going to be 3. So that means I need to multiply this by 3, which means I'm multiplying my hypochlorite by 3. So when I write this out, I'm going to have Al ClO. I had to multiply it by 3. Multiply it by 3. All right, we'll do one more example here. All right, lead 2. Lead 2 means that I have a +2 charge on that. Phosphate is PO4 -3. What's my least common multiple between numbers 2 and 3? If you're saying 6, you're right. So my LCM here is 6. So what do I have to multiply 2 by to get 6? I have to multiply this one by 3. What do I have to multiply 3 by to get 6? 2. So when I'm writing this out, I can write this as PB. How many of those do I have? 3 of them. Then my phosphate, PO4, how many of those did I multiply it by? 2. All right. So now this lead is contributing +6 to our charge. This phosphate is contributing -6. So our overall charge then becomes 0. Okay, so lots and lots of practice problems with this. You have to know your ions. You are not going to be able to use your ion packet. You are not going to be able to use a periodic table. You have to know your ions in order to be successful in this unit. Okay, so make sure we're studying those ions. Go through, do your practice problems. Make sure that you're writing out your charges like I did here. And make sure that you are confirming that your charges cancel. All right, so go ahead, work on some practice problems, check your answers, let me know if you need anything.